Okay, so let's start our system design. And today I am going to talk one of design system design concept and named as a fault tolerance. Okay, so sometime whenever you are designing your system, general one of the guidelines, your system should be fault tolerant. That means any kind of fault means any problem, any bug, any unwanted situation happen. And in those scenario, our system how behave. Okay. So we as a system designer, our responsibility, we have to design our system. If any kind of error, problem, fault, some expected behavior event happen in a system, in those scenario, what our system behave, what the expected behavior of the system. We cannot say I don't know what system behave. This is that means while system designing, we are not considering those scenario. If my database down, or my server space full, or some network cable fail, or any kind of hardware, software, infrastructure, something unwanted happen. So in those cases, what our system behave, we must define, we must consider, so that key whenever we talking to the customer, we have to tell them in this situation, if something fault happen, our system behave this way, this kind of output, this kind of response you take. That means while system designing, we have considered the failure cases as well. As so fault tolerance is the one of design concept which deals the unwanted event happen on your system. So let's talk about some fault tolerance. So as fault tolerance is the ability of system to continue operating correctly and providing its intended function even one or more its component fail or faulty. So generally whenever you are designing system, in your system multiple components work together and serve the request purpose. Okay, and these are the request components. If any one components are fail or become a faulty, in those scenario, how our system still should be operate, it still should be continue, it still should be function. This is the first objective, and they give me the right intended behavior. Here say correctly and intended behavior. That means we as a system designer know if something fault happen, our intended function or intended responsibility of the my function is this. You cannot say our system unexpected any kind of a response they are going to return. That means we are not designs a system for the event that are not as per my expectation. So here answer is intended function. The way system is designed, this way it must be function, it must be continue. You cannot say if my program is going to something and something unwanted event happen, complete whole server crashed and down, and we are not getting any kind of a proper response or some kind of message to the user. User suddenly unaware what system behaving. This is a very bad user experience. So it is a very good, you have to consider all the positive scenario, success scenario, that's good. But as a system designer, our responsibility also think and consider the failure, unwanted event, unfavorable situation, then our system how respond. So this complete failure management or the faulty case handling come under the fault tolerance design concepts. Okay, so hope clear what the fault tolerance means. If someone say, hey, whatever the system you build, that is fault tolerance or not. If you have already considered the unexpected event of failure, faulty, then you can say, yes, my system design is capable to managing faults. That means here we are going to provide the proper treatment, proper flow if something unwanted event failure happen in my system. Okay, so before jumping to the details, let's talk basic terminology, how we can manage this fault. So for managing fault, couple of basic things we have to consider. First, the redundancy. So very critical. Let's see, this is the components which are serving user request. Anyhow, let's see, our server crashed or power failure happened of this machine. Then what do you think? What the alternative to fix? Somehow we have to a backup or similar kind of redundant server must be ready, so that if something is unwanted happen, our request again routed to the different kind of system. So here duplicating critical components to ensure that if one fail, another can take its place. The best way, simple way, if you know this is my payment system or this is my profile system, this is my product system, and critical, I don't want my payment should be failure if the customer already ordered them. So you have to make duplicates, redundant, similar kind of components running in parallel, so that in some cases something unwanted, some failure happen, immediately second component take over those scenarios. This is the one way to handling fault, means make a redundant, make a duplicate copy of those components. And second things we have to also talk failover scenario. So if something, if you decided I make a duplicate redundant server to serve my the critical component, that's good, that's good, request is going handling. If something wanted happen, this is the crashed. So question, how it is going to request routed to the next? Is it manual process or what? So generally failover means automatically switching to the redundant components or system in case of failure. So if something failure happen, switching request routing to another component that's are healthy, that must be, if automatically, then you can say our system is handle failover case. And third kind of problem, error detection, identifying when the component or system has failed or is faulty. So is our system designs is capable to identify when my system is going to problematic. Let's example, you have a 10 GB or RAM or memory. You know continuously you are receiving data from the users, even storing. You know after which rate my storage going to the fill, after some time my database file system going to the full. If new requests come, might be you are say, hey, I am out of storage. So those scenario, why not our system automatically identify, hey, this server is automatically going out of storage full or going to the CPU outage or something. Each your system somehow you designs so they can predict they can identify, they can detect. That is the very good. Yes, our system before going to crash, before going to fail, I can find out this system is going to faulty. So let's recover them. Let's replace with another one. So that is the second very important point. You have to identify, your system must be identify the faulty case. And the list are not but lots of things, but if you identify, if you detected, hey, now this server is maybe problematic in coming 1 hour or 2 hour or 1 day or 2 day, so what it is possible, automatically you can take some action. So taking corrective action to prevent or recover from the failure. So don't both cases, if something failure happen, then your system automatically recover, or if it's they are already predicted something going to the fault happen, so is it our system can able to correct them. So faulty error problem can be detections, and corrections is also one of the key management in the fault tolerance. So first is the redundancy, second is the automatic switchover, third error detections, and fourth error correction. These are the very basics characteristics of any system that you can say designs for the fault tolerance. Okay, hope you are getting something about the fault tolerance. So let's talk the types of fault tolerance. Because whenever you are designing system, multiple layers of system, multiple components integrate to each other, and they are serving the our system designs. So these are the very basic kind of fault can be happen in your system. First, and maybe whatever the hardware you are using, maybe CPU, maybe RAM, maybe hard disk, maybe cable wire, maybe router, any kind of hardware, whatever you are using hardware, might be chance that can be faulty, that can be crashed, that can be not function a particular event, maybe power outage, network cable crash, something. So if you think any kind of hardware fault, or maybe some kind of a software fault also, whatever the way you build the application that's running on a software, maybe logically you are having some problem or fault can. Similarly, because your multiple hardwares are working and they are connected to each other with the networkings, so is our networks have any problem, not properly routing the call, network over uses, or network bandwidth is something high, maybe. So might be you are using, might be applications. Generally on hardware you are using multiple servers such as software, maybe Windows, email, these are the softwares. Somehow you can already build your application, your custom application on the top of this hardware, and software on the top of that you are running your application. Like my hardware is the your hard is like your CPU, hard disk, RAM, and my software is the Windows OS operating system, and after that we are running your my any application server. So maybe problem with the application server, or in the application server you are managing, handling the customer data, you are receiving data, responding data, storing data. So might be problem can be in the data side as well. So fault error can be happen each layer, each component, each part of the system. So you have to think and consider for fault management, error management, or on for each component, for each layer, hardware, software, network, application, and data. Lots of more, but yes, these are the very basics. You have to manage them. So let's talk about like hardware fault. So as I'll already discussed, using the redundant hardware component to ensure the continued operation, because you are using the multiple redundant server. If something failure, one of them may fail, another will fail, then how you can do? So maybe something multiple power supply issue, or maybe data center problem, still our application should be run. Good example like Google data centers are redundant, and the hardware to ensure that highly available. So whatever the hardware we are using for redundant server, please ensure that so they are very capable for available. So maybe you can use HP hardware, Dell hardware, Cisco, IBM. These are the vendors. They are basically providing this kind of a hardware that are the managed fault tolerant. If something failure happen, they give an option how to switch to another. So even the technology we can use to implement maybe kind of clustering or mirroring or redundant array of independent rates, right? Uh, redundant array of the disk, you can say multiple layers you can apply. So hardware levels, you can also ensure that ensure your redundant server is always available. If something failure or any kind of failure, you take care of those. And similarly, if we talk about this software failure, maybe whatever the software techniques to ensure the continued desired operation, even the hardware or software failure, both scenario. So somehow you have to identify the error from the code or detect the correct data correction something. So for that, if you talk about the Microsoft Azure cloud platform, uses the software like a fault tolerance to ensure highly available your system. So maybe you can use the Microsoft level software or AWS, IBM, Oracle. They are providing the software level, maybe either correcting codes, checksum, help, self-healing algorithms. Ki automatically something problem happen, you can feel them. So somehow, if any kind of softwares and hardware using some software, so there would be some kind of a mechanism where you can detect, hey, this is the problem in this software component, and then how we can automatic heal them, automatic correct them. And similarly, if we talk about the data fault tolerance, yes, so whatever the data informations you are receiving from the customer, sensor data, automatic input, or any integrated systems, you ensure that your data integrity and availability despite the hardware and software failure. What happen, you are collected data from the particular user profile and store in the database, one database, and what happen in after some time your database is crash. So you cannot say, hey, now we lost our data. So fault tolerance, you have to ensure that whatever data correct form is stored at the is available, even your hardware failure or software failure, whatever happened, you have to ensure that, because you receive the customer data and you have to manage, hey, we can provide. So generally these the data integrity and availability we can do. Again, data replications, backup, and to ensure that data availability, you can make the backup of data in the every instance on different location, different region, so that something problem happens, something hardware failure happen, database failure happens, file system failure, we have already available the backup data to restore them, right? So even you can use similar kind of a Dropbox, use the data replication and backup to ensure the user profile, file, images, videos are properly managed. You cannot say now we are uploading our videos on a face so social media networking platform. You cannot say, hey, social media networking platform, say, hey, somehow our hardware failure, you lost your videos or you lost your very important files of folders. So those scenario we cannot serve. So whatever the like ensure vendors, they provide, hey, whatever data you are storing, we are giving the guarantee they will always available for you. So for storing data, file, content, movie, picture, any documents, you can use maybe Dropbox, or you can use Amazon S3, yeah, Google Cloud Store, or Microsoft Azure Cloud Store. They are providing the very high kind of available and the data integrity, reliability to store your data. Even don't you think any kind of failure happen? Even for these vendors implemented technique, data replications, backup, checksum, digital checksum, whatever the data is storing, they cannot lost any bit, any data error corrections. Lots of techniques they are using, but you ensure that whatever the data receive your system from the customer, from the sensor, from the weather, from any source of inputs, your responsibility that you have to maintain correct data and available data. You cannot say, hey, our hardware failure, our software failure, our data center crash, so I lose your data. No, Similarly, if you are deploying your applications, that you ensure that your application availability and functionality despite the hardware and software failure. Any kind of failure happen, our application also should be available and run. So you can say using the application level replication or failover to ensure that continue operation. So here fault management are each layer you can have to apply. Even you can either Netflix are already uses application level replication and failover to ensure that streaming services remain available. So one is the hardware, one is the software, which software run your application, then application. So each layer. So generally, if you talk, this is your hardware, and then you are using some software to run your hardware, and after that you are using the application. So hardware level fault management, or of software level fault management, and your application level also you can install the same application instance in the multiple hardware, multiple server. So kind of application level replica means same instance you are deployed in the multiple servers, and if something failover happen, the failover situation you can also take care. So good example, you can use Netflix for that, AWS, Microsoft, IBM, and they are providing the application level replication and failover scenario and good designs. We talk about the microservice architectures, different instance of the one of the different components we are installed, we are deployed. So all are the, while implementing fault, still you face some kind of limitation, some kind of challenges. So while designing system as a fault tolerance, you have to keep in mind these challenges as well as these limitations. So whenever you are going to increase any kind of additional management kind of things, you can increase the complexity in your system, because if your system is very simple and you're putting something more and more handling, that means your system become a complex. So fault tolerance can be added to complexity in the system, application, and data, and making more difficult to design and implement and manage. So please be carefully manage this fault tolerance. You cannot say something design that drastically impact every layer, every challenges. And notice that these fault tolerance can be hardware level, software level, application level, data level. So they introduce some costing, because the fault tolerance can be more expensive to implement and maintain, because multiple rates, multiple arrays of systems you are going to take, and especially for the HA availability and applications. So you also be aware, if you are designing system that's highly fault tolerance, so your system going to the very higher cost as well as. And even because please ensure that if you are implementing fault tolerance, can reduce some level of system performance, because somehow you are going to duplicating data, ensuring the system checksum every request. So for multiple level systems are running in parallel, so in this case somehow one more component you started the, hey, how to check the particular system is going to crash or system failure, CPU usage, some extra process, extra code you are going to run to error detect or error correct. So somehow in overall our system performance going to little bit reduce as well as. Be ready for that. And might be some trivial failure, you can maybe fault tolerance can be maybe trivial mistakes, fault are more difficult detect and diagnose and underlying problems. Please be ready. While implementing this, you can find some different kind of, and also this is the challenges to testing, because whatever the fault tolerance mechanisms you place them, make some level of testing and validations, maybe application layer, maybe software layer, maybe data layer, so that you predict, yes, something happen, then what my system behave. Because this is a theoretical, let's give my hardware failure, what happened, until you are not testing, it is very hard to commit, hey, our system behave like this way. So sometimes this kind of system to testing and validating, it's also very challenges. So you have to think, you have to plan how I am going to plan testing and validating such a fault tolerant system, maybe hardware level failure, software level failure, application level failure, data level failures, and how whatever the system you design either detection, either correction, it's working and not working. So our objective is not just in designs and implements. Our objective, we have to some level of testing also available, right? So whatever the things we discuss, fault tolerance, and last class we discuss fault tolerance. Any systems you want to make a fault tolerance, make a redundant, right? Make a redundant. The similar kind of notice whenever we talk higher availability. If you want your system highly available, you can make a multiple instance scale 1, scale 2, scale 3. So somehow many initial system designer confuse your HA designing and fault tolerance. Sometimes they are confused, sometimes they can understand the same thing or different thing. So let's talk together. So last class we talked about the high availability. That means ki whenever our user highly requests come, our system is able to manage. So one system will not manage, then you can scale them, add one more server, add more server, add more server, redundant, and request started to different server. So here let's talk both now. What do you mean by fault tolerant and what do you mean by HA? So you can get the actual pictures. I'm going to some basics, not more detail about the HA and fault tolerance. So here you notice in HA, our objective is that our ability, HA provide the ability our system be accessible and usable, and how they almost try to uptime, always be ready to respond. Generally many organizations provide 99.99% uptimes, and also you have to minimize your downtime. If something unwanted, something failure happen, we are going to ensuring your the downtime as minimum as. So here high available system is the higher objective. Your system is be available at most, and if something going to down, so downtime as minimum, so that we can ensure that less data loss happen. So this is the high level objective of our HS system. But compared to the fault tolerance, the objective of the system, our system still continue operating correctly when one or more component fail or unavailable. So here objective is some drastically different. Here fault tolerant objective, if multiple components are redundant, if something failure happen, what are the way our system is still continue working? So this is the way. And generally here the objective of the fault tolerant system, whatever unwanted something failure, something error happen, that should be masked from user maybe doesn't aware, hey, something failure happen, and ensuring that still system remain function and data is not going to the lost. For example, like here a database systems, if multiple nodes, each multiple have a multiple disk, and maybe multiple disk, one disk failure, so system automatically switch over to another disk and without interrupt is database operations. Similarly in the case of your HA, whatever the web application, multiple load balance with a multiple load balancer, each routing different to multiple web server. If one server fail, load balancer automatically redirect traffic to the another available server. So here objectives, we are serve as many as number of users, because our ability, I'm always available to take responsibility. So multiple in this way. Here intention is, if something unwanted, something failure happen, in those scenario, how our system is still continue and still system run. So this is the major, you can say, understanding between your highly available system and fault tolerant system. Nowadays all the big and critical applications offering the both things, okay, both components. So if you talk some more details about the, so here our objective of a highly available system is we can minimizing our downtimes. So main focus of HA highly available system is that our system is as minimum as possible are going to the down. Here main focus is that to maintaining system always operational instead of if any kind of component, any kind of failure happen. So this is a different scenario. If something failure happen, in those cases our focus of fault tolerant to system must be operate. Okay, and here failure detection rely on the human intervention to detect and respond to the failure, and here system automatically detects and correct the data. So somehow nowadays both offer the automatic availability and failure detections. Okay, and similarly somehow the HA is try to achieve the simpler means such as a load balancing, clustering, failover. These are the high level concept. Generally if you implement your application, you apply load balancing, multiple clusters, apply the failover scenario, that means your system is very highly available. But here require more kind of complex architectures and techniques such as a tripler modular, redundancy, error corrections code, something more complex than the HA. So you can say here our redundancy is a very less, but here more comprehensive redundancy required. Maybe here you can say HA is the compared to the your fault tolerant system. Fault tolerant system is very expensive, and compared to the high availability is compared to fault tolerance is less. And so these are the some kind of different points you have to consider while talking to the HA available system or fault tolerance system. So overall you can say this is very fit or generally use any web application system, e-commerce platform and other system where you are thinking the downtime can be tolerated for some period of times. So here you can say your system is HA, but sometime for a minute, for hour might be downtimes can require, can be, then you can say your system is highly available. But still the chances that downtime can be minute, can be hours or something. What kind of the HA algorithm, active passive you implemented. But the fault tolerance systems are very specific. Say we are going to design system require the zero downtimes. If any kind of failure happen, still our system would be operate. So here generally any critical infrastructures applications or maybe any real-time systems or maybe any safety critical system, in those scenarios generally where you customer say I need a zero downtime kind of system, so your system must be designed for the fault tolerance mechanism. So let's talk some real world example which they are both highly available system and fault tolerance are using. So whatever the big you can say our players like Google search engine use is the highly available system as well as a fault tolerance architecture to ensure that search result always be available. So here not the only they design the highly available system plus fault tolerant as well as. So similarly we talk about AWS provide the highly available and fault tolerant system for the business. Even any financial trading system, that's also very high available and fault tolerant to ensure that all the trade, all the transaction going executed very quickly and correctly. So all the banking system, insurance system, market system, trading systems are generally highly available plus fault tolerance. Even if you talk about the air traffic control system, they are very highly available and fault tolerant system. If any kind of air traffic control something fault happens, something problematic happens, still they have a highly available and designs a system they can always operate even some fault situation happen. And almost similarly e-commerce platform nowadays, whatever we are using for social media or e-commerce application, that's also very highly available and fault tolerance. So generally you can say the big players where the high customer base and required kind of reliability. So such systems you must build for the both concept. High, your system must be highly available and must be fault tolerant as well as. And if you look some again case study, so those like all the big players, whatever they are you are using, generally they are still you can say designing system that's a very uh, high available and fault tolerance. Okay, so I'm talking some use case scenario where a couple of big industries are still using these our applications. That means whatever the system, if you talk about Netflix already designs highly available and fault tolerance architectures to ensure that customer can always be access their favorite TV show and movie, even something for their if you are watching some movie or something, if some node failure happens, some hardware failure happen, still Netflix ensuring that you are still continue watching your movie without any kind of interruptions. It is possible only because they have design system very highly available and fault tolerant as well as. Similarly, Amazon I discussed, they very highly available and fault tolerant architecture to ensure that customer always shop their website and access their custom cloud services. Similarly, Google also provide a high available and fault tolerance architecture to ensure that customer can always access their search engine. And similarly, Facebook also high available and fault tolerant architecture. Twitter high available and fault tolerant architecture. So if you notice, almost all the big players, Netflix, Amazon, customer, Twitter, LinkedIn, they are implemented our system very highly available and as well as the fault tolerance, because they don't want data loss. They don't want our system predict unbehavior, undesirable outputs. So let's look some reference architectural documents which you saw these already implemented by the different system. Even you can just Google it, whatever the you are using like Netflix or AWS or Amazon, whatever the system you are using, you can take this example, and they already all the reference architectural document you can find how our system should be highly available. Notice by default HA high availability, like AWS offers our S3 standards 99.9 available, EC2 90.995, and RDS is 9.9, and these are the same kind of highly AWS system available. Hey, anything come, if some it's everything fine, they are going to store somewhere. If something maybe a hardware level failure happened or some software level failure happened, still our system is working from a different route, a different workflow. So here objective is that our systems may be highly available, and if you talk about the fault tolerance, they also decide, say our system fault tolerance, if something maybe this region one have a something unwanted scenario happen, something problem happen, so here AWS using the route of S3 and completely change the route from here to the here if something failure happen. So still our system is always working, always responsive, even something failure happen, maybe some failure happen here or failure happen here, so we are switched to the another region, you can say, and similar kind of infrastructure already deployed. Okay, so this kind of different kind of reference architecture you can take and just Google it, you can say, and you can find different architecture for LinkedIn, for AWS, for Google, and they have implemented very you can say fault tolerance system as well as for all the mission critical applications. So fault tolerance generally, like here ensure that AWS also here different very, if you notice, like a different kind of 99% downtime maybe in 1 year 8 hours or 46 minutes somehow. And if your system is very fault tolerant, you can say zero downtimes and 100% availability. So here, if we be carefully observe, okay, so here these are the highly available system, highly available system, highly available system. In overall, in year, AWS commit maybe 8 hour downtime can be, yeah, 52-minute downtimes or 5-minute downtimes, depend upon the cost you are apply. So basic simplest way you can go, still 99.9 means in 1 year might be your system get to downtime for 8 year and 46 minutes, or 99.99, that means they are ensuring that only in 1 year 52-minute and 36-second downtime can be in 1 year, not the on a day. If you say 99.9999, that means your system is very very highly available, 5 minute and 15-second downtime in a year only. My whole year only 5 minute your system going to somehow down. But you can say your system is all fault tolerant, you can say your 100% availability and 0 down times. So such systems you can design and be focused. Maybe your costing also very region, because these are cloud service provider. If you want see kind of fault tolerant systems and 0 downtime kind of things, then we have to design such system like this way. Here different region basis, and region also different zone. So here like whatever the user accessing, they are using the routing route S3, and here maybe elastic load balance in different region, and different region always go to the different available zones. One zone failure, still another zone is working. If both region failure, still another region also be different zones. So in this way you design system that can make our system more fault tolerant. So whenever designing fault tolerant, that means you ensure that customer reliability, resiliency, redundancy, and monitoring tools are available. So you can say lots of designs, reference architectures available for free. You can say, and just you can say use them to understand how these systems are designed. So overall, the objectives of the talk of the today is that whenever you are designing system, you also ensure that depend upon the customer use, somewhere you can define your system HA might, and sometime you can define system plus your fault tolerance as well as, or sometime only HA is available, some 0 or some downtimes is acceptable for the customer, you can go just for HA. So these kind of capability still all the maybe customize the service if you are using, you can do, or if you are using the try to use the cloud provider services, they are offering kind of a high available system plus fault tolerant as well as. So depend upon your customer needs, customer requirements, what kind of system you are designing, what number of user base, what number of data sites, what percentage of criticality. If your application is very very critical, life saving, surely your system must be fault tolerance plus highly available. If you can manage some kind of a downtimes, 5 minute, 10 minute, 1 hour, 10 hour in a year, it's okay. Let's go design system for very highly available, that's okay, because here also much cost differences you find whenever you're going to evaluating these technologies. The cost is also very very key parameter, make differences for a system design. If customer is not ready to pay those kind of cost, might be you can think some alternative solution for customer, where you can just go with a highly available system, some downtime, just tell them customer. Okay, so hope this information about how you can design systems that should be highly available and plus system should be fault tolerant. That means your system must be manage, behave, operate, even any kind of any level of the fault or error happened. Hope this information helpful for you. Thank you.